When I'm prepping for one of these deep dives, I'm usually looking at the story,
Hmm.
right? The characters, the plot,
Yeah.
the stuff that makes you feel something. But today, we're looking at Harry Potter, one of the most loved series ever, and we're not talking about the magic. We're
Wow.
talking about the math.
It's a bit of a change of pace for sure. We're sort of taking the wand apart to see how it's wired.
Exactly. We've got this really fascinating research paper from Robert J. Ashcroft at Tokai University. It's called Harry Potter and the Maturity of Language.
The title sounds a little academic, maybe a bit dry.
It does, but what it's asking is, well, it's kind of wild. It's basically, did J.K. Rowling engineer these books, like mathematically, to grow up with her readers?
Or, and this is the other side of it, did we just feel like they got more mature because we were getting more mature as we read them?
Yeah.
Is the complexity real or is it just nostalgia?
I think we've all had that feeling, though, right?
Yeah.
You read the first book, Philosopher's Stone,
Yeah.
and it's a bedtime story. It's cozy. Then you get to Deathly Hallows, and it feels heavier. And I don't just mean the page count, although that was definitely heavier, too.
Oh, yeah, the physical weight is real. But Ashcroft's whole idea is that the linguistic weight gets heavier in almost the exact same way. And to check, he didn't just read them, he treated them as a corpus.
A corpus, that's a word I hear more in, like, data science, not literature class.
It's a linguistics term. A corpus is just a huge collection of texts that you analyze for patterns. You stop looking at the plot and start counting things. He digitized all 7 books, that's over 1 million words, and just fed them into software.
So we're talking about counting syllables, sentence length, word variety. It's like Moneyball for Hogwarts.
That's a perfect analogy, actually, yeah.
Yeah.
He's looking for the hidden stats that make the writing work.
Okay, so before we get into the numbers themselves, which are, frankly, a little shocking, we should talk about the why. The paper grounds all this in adolescent language development. Most people just assume that once you're 11, Harry's age in book 1, you're kind of done. You know English.
Yeah, that's a really common misconception. We think of it as a toddler thing. You learn your basic grammar by, 5 or 6? But the brain is still doing some major rewiring all through your teens.
So what's actually changing between 11 and 17?
It's a big shift from the concrete to the abstract. An 11-year-old is great at saying what's right in front of them. The dog ran, the potion is green.
Simple cause and effect?
Exactly. But a 17-year-old's brain is building the hardware for nuance. They start using more specialized words, and this is the key part, they use more complex sentences to connect different ideas.
So the dog ran becomes something more like the dog, which had been suspicious all morning, ran with a sense of grim determination.
Perfect example. Subordinate clauses. You're embedding ideas inside of other ideas. The sentences get more complex because the thoughts are getting more complex.
So the big question is, do the Harry Potter books actually follow that biological curve?
Let's find out.
Let's start with the first metric, because this is the one that really blew my mind, the polysyllabic surge.
This is the headline. If you remember one thing from this deep dive, it's probably this.
Okay, so a polysyllabic word is, what, 3 or more syllables? The big ones?
The big ones, yeah. The ones your brain has to consciously decode. Like the word wand is instant. The word incantation or institutional takes a split second longer to process.
Right, so Ashcroft runs the numbers. In book 1, these big words make up about 4.99% of the text. So basically 5%.
Which is pretty standard for that age group. It's easy to get into.
But then you jump to book 7, and that number is up to 8.39%.
Now, that might not sound like a huge jump, just 3.5%. But in this kind of analysis, that's a massive change in the texture of the writing. It's the difference between, say, a magazine and a college textbook.
But it's not just the jump, is it? It's the line between book 1 and book 7.
Yes, this is the Moneyball moment. If you plot the percentage for all 7 books on a graph, the increase is an almost perfectly straight line going up. The statistical correlation, the rod value, is base 0.99.
Okay, I am not a stats guy, but I know 1.0 is like a perfect match. So 0.99 it's almost too perfect, isn't it?
It's kind of unheard of in the humanities. You see that in physics, maybe? But for language, there are always weird variables. A 0.99 correlation means that as the series progressed, the vocabulary difficulty ramped up in almost perfect, predictable steps.
It's like J.K. Rowling had a slider on her word processor that just said reader age, and she just nudged it up a little bit for each book.
It really feels that way, but it's probably more about the themes. The ideas get bigger, so the words have to get bigger. You can't write about institutional corruption or prejudice using only 1 or 2 syllable words.
So we go from magic to Theoretical incantations.
Right. From bad guys to systemic prejudice. The words grow because the world is growing.
So the books were basically acting as, like, a personal trainer for our reading brains.
Yeah.
Book 1 is the 5-pound weight, Book 7 is the 50-pounder. But the ramp-up was so gradual we barely noticed we were getting stronger.
That's the key. If you just handed an 11-year-old Deathly Hallows, they'd probably bounce right off it. It would feel too dense. But climbing that ladder one rung at a time, you don't really notice how high you've gotten.
But it's not just about long words. The study also talks about variety, right?
Right.
Lexical diversity.
Right. And this is a bit trickier to measure because naturally, the longer a book is and Order of the Phoenix is massive, the more you're going to repeat common words.
Sure, you can only say Harry or said so many times.
Exactly. So a simple word count isn't fair. So they use something called Gouraud's index, which is a formula that sort of levels the playing field between long and short books.
And what does that index show?
Even when you adjust for length, the diversity climbs steadily. From the first book to the last, the variety of her vocabulary goes up by about 20%. So she's not just using longer words, she's using more different words.
Okay, which brings me to my absolute favorite new term from this whole paper. I am going to be using this. Hapax legomena.
Hapax legomena. It sounds like a spell, doesn't it?
It totally does, but it's actually Greek.
It means said only once. In corpus linguistics, it's any word that appears just one single time in the entire text.
The one-hit wonders of the word world.
Exactly. And the number here is it's wild. The paper says that somewhere between 39 and 45% of all the unique words in the whole series are these one-offs.
Wait. So almost half of the unique vocabulary in Harry Potter are words you see once and then never again?
That's what the data says.
Why? Why would a writer do that? It sounds so inefficient.
I think it's the opposite. It keeps your brain engaged. If you use the same 500 words over and over, we get what's called lexical fatigue. Your brain just starts to skim.
Right.
But if she throws in a word you've never seen before, like garrulous or labyrinthine, just once, it forces you to stop and visualize. It's a little jolt to the system.
It keeps the texture of the book from getting repetitive, even when it's 800 pages long.
For sure.
Yeah.
But there has to be a balance, right? You can't have every word be a one-off.
No, it would be unreadable.
Right. And that's where the study looks at something called the General Service List, or GSL. These are the 2,000 most common everyday words in English.
The building blocks. The and house, go.
The foundation. And the study finds that in every single book, from start to finish, about 75 to 78% of the text is made up of these basic words.
So the floor is always stable.
The floor is stable. But then you look at the academic word list. These are the fancier university-level words and the use of those doubles between book 1 and book 7.
So she keeps you comfortable with the simple words, and then she sort of sprinkles in the harder academic words to make you smarter without you noticing.
It's a classic teaching technique called scaffolding. You build on a strong, simple foundation.
Okay, so we've done words. What about sentences? The actual architecture of the writing.
Syntax. This is where you can really see the maturity kick in.
So the metric here is verbal elements per sentence. I'm guessing that's just counting the verbs.
Roughly, yeah. It's a measure of how many actions or states of being are packed into one sentence. In book 1, the average is 1.23.
So most sentences are like, Harry ran, the owl hooted. Simple, one action.
Pretty much. But by book 7, that average is up to 1.58.
That feels like a really small change. We're talking about decimals.
It sounds small, but in linguistics, that's a huge shift in the rhythm of the prose. It means you're moving from simple sentences to complex ones. You're not just getting Harry ran, you're getting Harry, realizing the Horcrux was burning him, stumbled backward while reaching for his wand.
Sentences that are doing multiple things at once.
And that forces your brain to do more work. You have to hold the first part of the sentence in your memory to understand the end of it. It's a big cognitive workout.
And the paper even puts a grade level on this using the Gunning Fog Index.
The Fog Index, yeah. It's a classic formula that estimates how many years of school you need to understand a piece of text easily.
So what's the verdict? What grade did Hogwarts get?
Well, book 1 scores an 8.9, so late middle school, maybe early high school, pretty accessible.
And the last book, Deathly Hallows.
That one scores a 10.45, so now we're in late high school, even pushing into early university territory.
So the books literally graduate with you.
They do, but, and this is where it gets really interesting, it wasn't that perfect straight line we saw with the vocabulary.
Right, there were some jumps. The paper says book 2, Chamber of Secrets, actually got a little easier than book 1.
And then book 4, Goblet of Fire, just skyrockets in complexity.
Why would that happen? If the words are getting steadily harder, why are the sentences all over the place?
Because the story comes first. I mean, think about Chamber of Secrets. It's a detective story, a mystery. There's a lot of action.
Right, running from spiders, fighting a basilisk.
You need shorter, punchier sentences for that. You don't want a long, complicated sentence when you're being chased. But Goblet of Fire, that book opens up the whole world. You have the World Cup, the other schools, the politics. The world gets bigger, so the sentences have to get bigger to hold it all.
The syntax serves the story. That makes perfect sense.
And that leads to maybe the weirdest finding in the whole study. The one thing that did not go up, lexical density.
Okay, this is the one that really confused me. Because you hear density, and you think of Book 5, Order of the Phoenix. That book is a brick. It has to be the most dense.
You would think so, but the data shows Book 5 has the lowest lexical density in the entire series.
How is that possible? The longest book is the least dense.
It's all about how you define density. Here, it's the ratio of content words like nouns and verbs to function words, or glue words like the, of, and, but.
Okay, so a sentence packed with information is dense. A sentence with a lot of filler is not.
Exactly. Now, what is happening in Book 5 for 800 pages?
Harry is angry. Very, very angry.
He's angry, he's arguing, he's shouting.
He's shouting at everyone. Ron, Hermione, Umbridge.
Right. It's a book that is completely driven by dialogue and interpersonal conflict, and spoken language is just, well, it's less dense than narration. When we talk, we use tons of pronouns, filler words, simple connectors.
So because so much of the book is just teenagers arguing, the mathematical density actually goes down.
That's the theory. The sheer volume of all that teenage angst just dilutes the overall score.
I love that. The algorithm actually picked up on Harry's mood swings.
It proves that complexity isn't just one thing. A book can have really advanced vocabulary but have a low-density score because the characters just won't stop talking to each other.
So let's pull this all together. What's the real-world takeaway here?
Well, the author of the paper works in Japan, where Harry Potter is a huge tool for people learning English.
Sure, that makes sense. You know the story, so it helps with the words.
But he argues that a lot of teachers just say, go read Harry Potter, and hand a student the whole box set.
And they hit a wall.
They hit a wall. The data shows books 1 to 3 are great for intermediate learners. But there's a big complexity cliff right around book 4. If you're not ready for that jump, you're just going to get frustrated.
So you can't skip grades. The series is its own curriculum.
It's a perfect graded reader. It just happened by accident.
Right.
Or maybe not entirely by accident.
Right, the Rowling factor. Do we think she planned any of this? Did she have a spreadsheet?
I need to increase my polysyllabic word count by 0.5% today.
Exactly. Or was she just becoming a better, more confident writer over those 10 years?
The paper suggests it's a mix of both. Of course she was growing as a writer, but also think about her power. When she submitted book 1, she was a debut author. Editors were probably cutting everything.
Right.
By the time she turns in book 5, she's the biggest author on the planet. Nobody's telling her to cut a scene or simplify a sentence. Success gives you the freedom to be complex.
So the data reflects Harry's growth, but it also reflects her own growth and her freedom as a writer.
That's a great way to put it, a convergence of the two.
So we've confirmed it. The magic is in the math. The books really do track our brain development. Which leaves me with one last kind of chicken and egg question.
Ooh, I like those.
If these books mirror adolescent development so perfectly, are they just a reflection of how teens think? Or are they actively teaching teens how to think in more complex ways?
The mirror versus the mold.
Yeah. I mean, if you picked up book 7 today without reading the first 6, would your brain actually struggle with that sudden leap in syntax?
And that's the big takeaway, isn't it? The study suggests we didn't just read Harry Potter, we trained on it. That series might have built the neural pathways for reading complex fiction for an entire generation.
So Harry was at Hogwarts learning magic.
And we were at Hogwarts learning how to process subordinate clauses. And you know what? I think we both came out better for it.
I'll take it. I'm definitely going to look at my bookshelf a little differently tonight. Thanks for nerding out over the data with us.
Anytime.
That's it for this deep dive. Keep reading.